Welcome to the deep dive. Today, we're going to pull back the curtain a bit. There's this invisible, really high-stakes race happening right now behind all our technology.
Absolutely. It's intense.
We're taking a deep dive into Samsung's part in this, specifically their big advancements in chip manufacturing. We're talking about their second-gen 2-nanometer gate-all-around process, SF2P, they call it.
Right, the GAA tech.
Yeah, and our mission today is simple. Let's try to unpack what these moves by Samsung really mean. For the tech world, sure, but also ultimately for you holding that phone or laptop. Let's get into it.
And maybe the first thing, just to set the stage correctly, is this whole nanometer thing. It's super common, right? You hear 2 nanometer, 3 nanometer.
Right, sounds incredibly tiny.
It does. And you'd naturally think that number, like 2 nanometer, must correspond to some actual physical thing on the chip, like, I don't know, the transistor gate length or something.
Yeah, seems logical.
But the fascinating thing is, and this often trips people up, these numbers, they're mostly marketing terms now. They don't, directly measure a specific feature size anymore.
So wait, there isn't like a tiny ruler measuring a 2-nanometer line somewhere on the silicon. That's actually surprising. It really shows how complex this industry's language is.
Exactly right. Think of them more as labels for a generation. A new label, like 2 nanometer, basically signals, okay, this is the next step up. It should give you better transistor density, maybe faster speeds, definitely better power consumption compared to the last generation, like 3 nanometer.
Ah, okay. So it's a relative improvement marker, not an absolute measurement.
Precisely.
Yeah.
It signifies a generational leap in capability. What really matters, the stuff engineers focus on, are the actual metrics. Performance, power, and area, PPA. Those tell you how much better the chip actually is, not just the catchy number on the box.
PPA. Got it. That makes a lot more sense. And framing it that way really highlights the pressure on Samsung, doesn't it? Because their position right now, well, it's challenging.
It really is. The stakes
Yeah.
are incredibly high for them.
Their global foundry market share, I think latest figures for Q1 2025 put it around 7.7%, which sounds okay until you compare it to the leader, TSMC.
Yeah, TSMC is the giant here.
They're commanding something like 67.6% in the same period. That's a huge gap. And Samsung, well, they've had some rough patches with their 3-nanometer and 4-nanometer nodes before this, right? Some clients apparently weren't happy.
They definitely stumbled a bit, lost some confidence, yeah. Which makes this 2-nanometer push absolutely critical.
So getting SF2P right isn't just about catching up technologically. It's about regaining trust, regaining that market traction.
It's fundamental. They need to prove they can deliver reliably at the cutting edge, not just once, but consistently.
Absolutely. And this seems to be where their own chips come into play, like the Exynos 2600 processor. I heard that's key to their strategy.
That's the internal proving ground, exactly. It's slated for their own Galaxy S26 phones. By using their own high-volume product, they can really ramp up production, work out the kinks, and crucially improve those manufacturing yields.
Right, driving those yield improvements is everything. So, okay, let's talk PPA then, the actual improvements. What are they projecting for this SF2P compared to, say, their last generation SF3?
The numbers they're putting out are pretty compelling. Compared to SF3, the 3-nanometer node, they're targeting about a 12% boost in performance.
12%, okay.
And, maybe more importantly for many devices, 25% better power efficiency.
Wow, 25% less power drain. That's significant.
Huge for mobile. And also a reduction in the physical chip area, somewhere between 5 and 8% smaller.
Smaller, faster, and uses less power. That's the goal.
That's always the goal, yeah. And just to be clear, there was an initial SF2, their first 2-nanometer version. SF2P is the follow-up, the second generation. It's refined, tweaked specifically for even better power savings, and that slight area shrink over the first SF2.
Got it. So SF2P is the more mature version they're betting on. But, these performance numbers sound great on paper. The real world of chip making, though, it always comes down to yields, doesn't it?
Always. Yields are king. It dictates whether you can actually make money, and just as importantly, whether clients trust you can deliver the volume they need.
So where are they with 2-nanometer yields currently? And what's the magic number they need to hit for this to be considered a success, commercially?
Reports suggest they've managed to push the yields over 40% recently, which is progress. But the industry benchmark, the point where it becomes really profitable and reliable for mass production, that's generally seen as 60 to 70%.
60 to 70. Okay, so still a way to go.
Still a significant gap to close, yes. And hitting that consistently, that's what builds that crucial client trust you mentioned. Clients need to know they can count on getting enough working chips on time. No surprises.
That makes total sense. Reliability is key. And speaking of strategy and maybe challenges, there was news that Samsung actually postponed their next step, the 1.4 nanometer development. They're focusing everything on 2 nanometer first. What do you make of that? Is that a sign they're struggling, or is it maybe a smart move?
I think it's more of a calculated strategic pivot. It signals they understand how critical it is to get 2 nanometers right. Stabilizing those yields, ensuring reliability. That's job number one.
So prioritize stability over just rushing to the next smaller number.
Exactly. A high-yield, dependable 2 nanometer process is far more valuable to customers right now than a shaky, low-yield 1.4 nanometer process that might look good in headlines but can't deliver in volume. It's about rebuilding that foundation of trust. Deliver a solid product first.
Okay, that framing makes sense, focusing resources. But of course, Samsung isn't doing this in isolation. You mentioned TSMC, and then there's Intel making a big push too. How does Samsung's SF2P strategy stack up against TSMC's N2 and Intel's 18A? They seem to have slightly different approaches.
They definitely do. It's not a monolithic race. Samsung, with SF2P, is clearly pushing for those strong PPA gains we talked about, performance and power. TSMC, with their N2 process, seems very focused on what they do best, achieving super high yields, high density, and just being the reliable volume supplier for a huge range of customers. They're the safe bet in many ways.
The workhorse.
The workhorse, exactly. And then you have Intel with 18A. They're being quite aggressive, pushing for performance leadership, and notably, they're integrating a new technology called backside power delivery relatively early.
Ah, the backside power, right. That could be a differentiator.
It could offer real performance advantages, yes.
Yeah.
But it also adds complexity and potential manufacturing challenges. So
Yeah.
each player is sort of optimizing for slightly different things, targeting potentially different needs in the market. It's not just about hitting 2 nanometer first.
That's a really important nuance, different paths to maybe different kinds of success. And one last area, diversification. Is Samsung looking beyond just smartphones for these advanced 2 nanometer chips? Are they trying to win business in other growing sectors?
Oh, absolutely. That's crucial for them. They have to diversify beyond mobile to fill these hugely expensive factories, these fabs. They're actively targeting high-growth areas. Think AI chips, automotive semiconductors, high-performance computing, even supercomputers.
Makes sense. Spread the risk and capture new markets.
Exactly. And it looks like it's starting to gain some traction. They've landed Qualcomm, a huge mobile player, obviously, for some Snapdragon chips. And interestingly, they've also reportedly secured business from Preferred Networks, a major AI company out of Japan.
Preferred networks, okay. That's a significant win in the AI space.
It really is. It suggests that confidence in Samsung's Foundry capabilities, even for these really demanding AI applications, is growing. It's a positive sign for their diversification strategy.
Okay, so let's try and wrap up the key takeaways here. We've dug into Samsung's big push with their 2 nanometer gate-all-around tech, SF2, and especially the refined SF2P. We saw the PPA goals, looking at, 12% more performance?
25% better power efficiency.
Right, 25% power and 5 to 8% smaller area compared to their last-gen SF3. Big goals. But we also talked about the challenge, the yields. They're over 40% now, but really need to hit that 60-70% sweet spot for profitability and, maybe more importantly, for client trust.
Which explains that strategic pause on 1.4 millimeter development. Focus all efforts on nailing 2 millimeters first.
Exactly. Get the foundation solid. And then there's the competition, this complex race with TSMC focusing on yield and density with N2, and Intel pushing performance and new tech like backside power with 18A.
Different strategies for different goals.
And finally, Samsung's smart move to diversify, looking beyond mobile into AI, automotive, HPC, and winning clients like Qualcomm and Preferred Networks. It's a broad strategy.
And maybe connecting this back for you, the listener, Samsung getting 2 millimeters right, it's not just about their own bottom line or market share numbers. It actually matters for the whole ecosystem. A strong Samsung Foundry provides a real, viable alternative to TSMC, a second source.
Which is good for supply chain resilience, right? Less dependence on one single company.
Precisely. It reduces risk for everyone. But maybe here's a final thought to leave you with. The semiconductor market, it's booming. Projections are massive, maybe hitting $697 billion by 2025. Generative AI chips alone could be over $150 billion of that. Huge numbers.
Growth, yeah.
But there's this other challenge looming over the industry. It's not about silicon, it's about people. There's a projected shortfall of something like 67,000 skilled semiconductor workers by 2030. So the question becomes, how much will this talent war, this fight for skilled engineers and technicians, actually shape the future? Could that bottleneck innovation even more than the physics of transistors?
That's a really powerful point to end on. It brings it back to the human element. This whole incredible race to 2 nanometers and beyond. It's not just about the tech, the fabs, the billions invested.
Right.
It fundamentally relies on having enough highly skilled people and nailing those incredibly complex operational processes.
Operational excellence, absolutely.
So, maybe something for you to think about. As amazing as the technology gets in your phone or your computer, these underlying constraints, finding the right people, running these processes perfectly, that might be what really dictates the pace of progress and what ultimately becomes possible.